All right, friends and neighbors, welcome back to another networking video. Hey, it's summertime, and I had a couple of suggestions for what to do over the summer. So maybe in addition to growing a summer beard, we'll talk about what's on our networks, and then maybe some upgrades or some builds to our home networks. And so that's kind of going to be the focus this summer. And so we'll really talk about two things, what's running on your network and how to understand what's happening. And then also, some components that are in our network. And I will try to remember, or I'll try to treat this as if we're all just getting started for the first time. And so our discussions will be, we'll talk about the basics and then we'll get into some of the more intense details. So let's take a look at what's on my network. And one of the first questions I asked, or as I'm building curriculum or teaching or even doing these, I ask a lot of times, why do we study what we study? And the reason is fairly straightforward. We study what we're studying because, well, that's how we build networks. And these are the protocols that are being used. These are the operations that go on the network. And so the example that we're going to do today is an actual Wireshark capture about stuff that's on my own home network. And so the reason that we take a look at the stuff that we're going to examine is because that's what's there. It doesn't make a lot of sense to study, a tremendous amount of protocols that are not being used. Sometimes we do that to understand things, but really this is about trying to understand how networks operate today. And so we'll take a look at how things work, what we do to build them, and then the protocols that are involved. And oh, by the way, while we're studying that, understanding those conversations, why things are there, what's going on, these are terrific skills to develop. Your analytics, your capability to take a capture or to take a network situation and understand what in the world is happening. So our topology today is really straightforward. So let me provide a couple of details here. The first is that we've got a couple of PCs. And my one PC is just going to be capturing the traffic that this other PC is generating. And I'll generate a little bit with this. So the device that I've got here connecting them is a hub. Now, hubs are the toasters of the networking world. They don't have a whole lot of intelligence. I just happen to have one running or sitting around on the shelf here, so I use that to interconnect. Now, if you were doing this at home or you had a different kind of device, you might set up what we call a mirrored port or a span port right here that would copy traffic from one port to another. I just happen to be using a hub. Now, when I say capture traffic, what does that mean? Well, I use Wireshark an awful lot. I mean, a tremendous amount. And so Wireshark is this cross-platform tool that is free. You can download it from wireshark.org, and I encourage you to do that to start developing those skills. It's a very, very common tool. On the Linux side of the house, and maybe a little bit more, difficult to use, is TCP dump. Very, very similar thing. There's a command line version of Wireshark called Tshark as well. Now, here is my home gateway, and this doesn't really matter what kind of network you're using or what kind of connection you have to the outside. Mine happens to be fiber. It was cable until a little while ago. Even if this is DSL, this device does the same thing. It's a gateway to the outside world, and the protocols that we're going to use are all going to be the same. The only thing that's different is the physical connection that you have to the world. So again, I'm going to generate some traffic on this node, and what I did was I shut it down and I started it up, and then I just opened up a browser. And over here I opened up a browser too. And we're going to see that there's a phenomenal amount of traffic that happens just taking a look at that. So let's do this. Well, here is Wireshark. And I'm going to point out a couple things here. First of all, that if we go all the way down to the end and take a look at the packet numbers, the entire time that this little experiment took was a little over a minute to shut down, to start up again, and then open up a browser. So we're just talking about it, maybe a couple of minutes. And it's 8,000 packets, 8,000 chunks of information that were sent out from these particular machines. Now, if we say, well, how does Wireshark work? What do we do with it? Well, we might say that Wireshark is about packet capture, and we might say that it's an analyzer. Now, the very first thing that I'm going to show you is that when we grab a particular packet here, this one happens to be a protocol called TLS, or Transport Layer Security. If I look at an individual packet, I see, and I close all of these, right? I can open all these up. But if I close all these, I can see that it's got my different layers here. These are our OSI, or TCP/IP model layers. So I have Ethernet, I have IPv4, I have Transmission Control Protocol, or TCP, and then I have TLS. Every packet has layers like this. They're not all the same. We have a lot of variation in that, but you can learn an awful lot just by taking a look at these layers. And each layer has a protocol, and each protocol has these fields. Now, we can talk more about the fields, we can talk more about the protocols and how they operate, and I'll add a bunch of links in the show notes to get you started. In fact, this kind of stuff is what inspired me to write my very first book, which was the Packet Guide to Core Network Protocols, which is this fabulous book right here. And there's a whole playlist on the channel dedicated to just the chapters in this book. Now, when we start to look at what's going on beyond individual packets, we might see that this IP address is having a conversation with this IP address. So it sent a packet from one place to another. And that destination responded. So there's a conversation going on between these two nodes. And so when we start to do a little more in-depth analysis, we start to say, well, what are all these conversations about? And that's another thing that Wireshark can help us with. So each protocol has fields. Each protocol set of fields has meaning, and then together a bunch of packets can have a conversation. Okay, cool. And like we said, in just this short conversation, there were thousands of packets generating. So what was my machine doing when it started up? What was my machine doing when it shut down? And what was happening when I actually opened up a browser? Okay. Well, let's take a look at, beyond just looking at packets, which is fabulous, of course, but beyond just looking at all of these packets, right? I mean, there's an awful lot of them. We can start taking a look at some of the analysis and statistics tabs that we have here. Now, for today, I think we're going to satisfy ourselves with a couple here. The first one that I want to take a look at is the protocol hierarchy. When I take a look at the protocols that are actually running, and remember that this was a capture that I did on an Ethernet connection. So that topology that I showed you was an Ethernet network. Well, between Ethernet and 802.11, these are the two most popular local area network protocols that we have. They're layer 2 protocols. And so when I collapse everything, we can see that 100% of the packets were Ethernet packets. And that makes sense because I'm on an Ethernet network. When I start to expand this a little bit, and we start taking a look at the next layer up, which is the internet layer, what I see is that I've got a couple of additional protocols because now we're moving from layer 2 to layer 3. So I can see ones that are recognizable. I've got IPv4 and IPv6. And then I've got something called logical link control, and we can see the percentages that are allocated to each one of these. Then I've got address resolution protocol. Now we could stop right there and say, let's talk a lot about IPv4 and IPv6 and ARP and what's going on at layer 2 and layer 3 here. But we can also notice that 91.3% of the traffic, 91.3% of those 8,400 or so packets were IPv4. And so while it's fun to talk about IPv6, and it's good to know, the lion's share, the majority of the traffic that I was generating that contained data was also IPv4. Address resolution protocol, its whole job is finding other folks on the network and really mapping IP addresses to MAC addresses. Okay, well, let's take a little closer look at what's going on in IPv4. Well, if we open this up and we take a look at our layer 4, or what's also going on at layer 3, we can see that there's the user datagram protocol and transmission control protocol. These are our layer 4 protocols. All of our applications use UDP and TCP. And then we've got something called IGMP, Internet Group Management Protocol. That is for multicasting. And then we've got some ICMP, or Internet Control Message Protocol. Not very many of those, right? Just 2 packets out of 8,000. When we start to take a little closer look at this, we can see that of those 8,000 packets, 91% were IPv4. And so of those IPv4 packets, 80% of those were TCP, meaning that there were applications or processes that were trying to get something done. Okay, well, most of them were IPv4, most of them were TCP. What's going on in TCP? Well, remember that the thing that I did, and the only thing that I did, was open up a browser on that machine over there and open up a browser on this machine here. I didn't do anything. All I did was open up a browser. And what this tells us is that there were a lot of packets generated just doing that. So an awful lot of packets were created just in opening up the browser and connecting to those things that are sort of your default tabs or your default links. But also, some of those conversations were the operating system itself. The operating system trying to find printers, trying to phone home, trying to do all of these other operations that modern operating systems do to optimize things or to establish their connections. Now, when we look at this, we go, wait a minute, this was 6,800 packets for TCP. And then we go, well, where are they? Well, some of them have an identifiable header, TLS or HTTP, which is browsing. Where are the rest of them? Where did they all go? Well, the rest of those are going to be in data, just TCP data. And so not this data, this is a different layer, but the TCP data. Now I'll give you an example of one of those here. Now in Wireshark, one of the things that's good to get a handle on is some of the basic filter rules. So this is my filter bar right here. And if I get used to some basic filter rules, you can put in a protocol there and just hit enter. And if I take a look at a packet like this, right, all these nice green ones here, if you can see the color. If I take a look here, all of these packets share something in common. They don't have any additional header. It's just Ethernet, IP, and TCP. And then some amount of data, whatever it is. But there's no additional header here, right? There's nothing underneath this. And so that's where the rest of the packets are. That's how we account for the rest of the packets. So if we continue our analysis a little bit, we can see that there's some, some header details about what was going on in HTTP, for example. Now, UDP is a protocol that we use for a tremendous number of protocols involved with getting our network operating or getting our connections established. So here we have the Simple Service Discovery Protocol, right, SSDP. A really, really big one we can find down here is DNS. That's how we find the names, or we map the IP address to the name that we're asking. So you go to a website, you don't know the IP address, DNS is there for that. DHCP, but all of these, NetBIOS, all of these are really about services for your network. And so this is all stuff that's coming to me courtesy of my gateway. Now UDP is also used for real-time applications. So if I happen to be gaming or watching a video or doing voice over IP, these would be examples of real-time applications that are not services, but that also use UDP. Now maybe before we leave Wireshark today, we'll just take a look at some of our statistics and the conversations that we might be having. So another thing that Wireshark can do is show you the conversations based on the different layers. So here are Ethernet conversations that that are going on. Now, they're not very many because this is just 2 nodes that were involved here. And so these are the MAC addresses that we're having conversations back and forth. So when I look in a particular packet and I look at the source and destination MAC addresses, these are the conversations that Wireshark is telling me about. If I wanted to understand more about what was going on at layer 3, we can see there are a lot more conversations. And that's because when you're an Ethernet node, you only have one MAC address, typically. Now here, that one node can have a lot more conversations. You can see, goodness gracious, there are a lot of IP addresses here that I was communicating with. So that's at layer 3. Well, what's going on at layer 4? Well, TCP and UDP provide those. And we can see that we've got the source and destination IP addresses, but also the source and destination port numbers, because these are values. Port numbers are what we use for addressing at layer 4. They're also what we call the other part of our socket connection. So we can see several conversations that we have, and we can take a look at the different layers. So that's another very nice thing to do, or to be able to do, with Wireshark. Now, one other thing that I think we ought to take a look at is the ability to follow a conversation. One of the things that I mentioned earlier was an importance in not only just understanding individual packets and fields, protocols, but those conversations. And so we can see right here, this is actually the beginning of a TCP conversation. I can tell that because I've got a SYN flag set here. Now, I might grab one of these longer ones. Let's say, let's go all the way to the top maybe. And we'll say, that's a finish. There we go. There's a SYN-ACK ACK. So this is the beginning of a TCP conversation. Now, if I right-click on this, we can see that there's a couple of things that I can do here. I can apply this as a filter selected, and that'll give me certain results. I can grab it as a conversation filter. I can follow the TCP stream. Now, it depends on what you're trying to do, but what I'm trying to get you to think about is there's a lot more to Wireshark than just being able to look at an individual packet. And so maybe what we'll do is a conversation filter based on TCP. Now look at this filter line. Good gracious me. That is a lot. And what it is saying is that it wants these 2 particular IP addresses. And one of the nice things about using one of the built-in features of Wireshark is you can see how these rules are constructed so that you can pick them yourselves or write them yourself. So what it's doing here is grabbing 2 IP addresses and 2 specific ports. And now I can see that I have the entire conversation of just these 2 particular nodes. It's also sometimes handy when you combine this with a tool like netstat to say, all right, what's going on my network, but also what is my machine trying to do? And by netstat, I mean something like this. So if I actually type in the word netstat, I can see the conversations that are actually happening, the processes that my node is actually involved in. Not very excited because I'm not doing very much right now, but there you have it. So that's when I said netstat. I've got to be careful that we just don't run very quickly and adding lots of terms in here. Well, I think that's enough for getting us started and kicking off the summer. So that was it. That was just that small topology, 8,000 packets, just one node starting up and shutting down, one node capturing, and then both of them opened up browsers. So this has been a little tiny investigation into what's on my network. Remember that we're dealing with a standard set of protocols, so it doesn't really matter if you were doing this on Linux or if you were doing it on an Apple device, if you're looking at a printer, what your PS5 does or what your Xbox does, it doesn't really matter. These protocols are going to be used on every single network by every single device because they're the way the world works. So no matter who you are, you're going to do Ethernet and 802.11, IPv4, IPv6, TCP and UDP, and ARP. Those are going to be extraordinarily common, and so that's why we study what we do. It's also been a little introduction to getting started with Wireshark. I absolutely encourage you to go out, get your free download, cross-platform, and have a little bit of fun looking into what's on your network. Well, thanks for watching. Thanks for listening. Like and subscribe, especially if you're kind of jazzed about maybe learning what's on your network, talking a little bit about things, and then maybe talking about how to upgrade or build our networks over the course of this summer. And remember, no matter where you are in your journey to understanding networks, you can do this. We can get this done, and I'll help, and we'll make sure that all those packets reach their destinations.